Hi friends, welcome back to the course on basic electronics. So now we'll discuss about full wave rectifier, right? So in full wave rectifier we have two types full wave rectifier. One is center type full wave rectifier, other is bridge full wave rectifier. So first see that in full wave rectification, see here, current flows through the load in same direction for both half cycle of input AC. Okay, we earlier saw that in half wave rectification only single half we have output. For single half AC input we have output, but for another negative half we don't have any output. I mean we have zero output. But in full wave rectifier we have output for both half cycle, negative as well as positive half cycle of input AC signal. Okay, so this can be achieved with two diodes working alternatively. So two diodes working alternatively in center tap full wave rectifier, but in bridge full rectifier we need four diodes. So for one half cycle, one diode supplies current to the load, and for next half cycle, another diode works. Okay, so on the next slide, see center tap full wave rectifier. As you know that this is a 230 volt 50 hertz AC supply, and this is center tap transformer. It converts step down voltage from 230 volts to 9 or 12 volts. So see, circuit has two diodes D1 and D2 and center tap transformer. This center tap transformer, this one is D1, this one is D2. During positive half cycle, diode D1 conducts, and during negative half cycle diode D2 conducts. See how it's looking like. In positive half cycle this D1 is in forward bias, but in negative half cycle D2 is in forward bias. So in positive as well as negative the output is here. Now it can be seen that the current through load RL is same direction for both half cycle. Yes, current is in same direction here. See, for both half cycle. There is no negative here, right? Okay. See full wave bridge rectifier now. Full wave bridge rectifier, it needs four diodes. As I said, this one is D1, D2, D3, D4. Need for center tap CT is eliminated. Okay, consists of four diodes instead of two here. So just remember this circuit and just come to operation or operate. See in positive half cycle is 0 to T by 2. T by 2 is time period. See, during period T0 to T by 2, diode D2 and D3 are conducting while D1 and D4 are in off state. So this is our actual diagram. Now see, in positive half cycle, this one is positive current flowing through here. This one is on because this one got forward bias in positive half cycle. See, this one is positive, right? This is anode, this is cathode. So it's got in forward bias. This one as well as this one is also in forward bias because current is flowing through this, and this like this out. But here this is in reverse bias because it's positive here and this one is cathode negative, so it is reversed bias. So there is no current flowing through this way. This is in off position. Same here, see, positive current flowing through this one by this one it's out, right? So come to next half cycle. See in negative half cycle diode D1, this one D1 and D4 are in on position conducting, while D2 and D3 are in off state, right? So current is following through this way, and out. So see, in both half cycle we have output here. Positive half cycle as well negative half cycle, both output we have output. Full wave bridge rectifier, right? So our one full cycle, the input and output voltage will appear as shown in figure C. This is input, whole input signal, and this is output, right? So VDC 2 into 0.318. This one is what? This is V maximum. V maximum means peak voltage of input current. This one is peak voltage, right? So in each peak voltage, see 0.318 V1, because see here I reduced some voltage here of input signal. Why? Because we'll see in next slide. See, I reduced some input voltage from here to here. See what happens if use silicon diode instead of ideal diode. See, in ideal diode there is no any threshold voltage for operating the diode, but in silicon diode we have some threshold voltage. Vt is 0.7 volt. So above that voltage only the diode gets active and current flowing through the diode, right? So this is current flowing through the from the input source, right? Here it's Vt 0.7 volts is dropping here, again here dropping here, right? So by using KVL in that loop, suppose this one is closed loop, by using KVL we got that Vm is full here peak voltage, this one is Vm, right, input voltage. So Vm minus 2 Vt, here also Vt one drop, here also Vt, so Vm minus 2 Vt is the output, actual output here. So VDC equal to approximate, we can say that Vm minus 2 Vt into this one is multiplied here, right? Now output frequency waveform of full wave rectifier. See, output frequency of full wave rectifier is equal to double of the input frequency. Yes, right. Because in as you saw earlier, in half wave rectifier, it's same as input, right? But here it's conducting both half cycles. This one also as well this one also. So this means when input as AC completes one cycle, rectified wave completes two cycles. This is two cycles completed, right? Rectified output completed two cycles as you see in the graph here, right? Now come to advantage and disadvantage of bridge full rectifier. Advantage is need for center tap transformer is eliminated, right? I mean center, no need of center transformer here. PIV means peak inverse voltage is one half of that center tap of circuit, right? Output is twice than that of center tap circuit. Output, we get output here twice than the center tap transformer. These three are advantage. Now come to disadvantage. It main disadvantage is required four diodes, so somewhat circuit is complex, right? Than the center tap circuit. Okay, and internal resistance voltage drop is twice than that of center tap. Internal voltage drop, yes, internal voltage drop is twice because we are using four diode here, so this voltage drop is twice. But in center tap we are using only two diodes, the voltage drop is half of that. Okay, so any question, if you have any question regarding full wave rectifier, so you can ask on the forum, we will discuss there. Okay, thank you.